Another important concept that we need to study when we are looking into organic chemistry is the concept of isomerism and the concept of isomers. Isomers are compounds that have the same molecular formula, so the same number and type of atoms, but that they are different compounds. They have a different arrangement of the atoms and the way those atoms are bonded. I here, for example, have a couple of what we call constitutional isomers or structural isomers, isomers that have a different structure. If you look at these two compounds, they are two derivatives of butane. They both have 4 carbons and 10 hydrogens. However, it is clear that they are not attached in the same way. That's what a structural isomer is. They have the same molecular formula, but the structure is totally different. And they have different melting and boiling points. They can have different colors because it's the interaction of the atoms with lights that give you the color and the movement of electrons, and the movement of the electrons is different depending on how the atoms are distributed in a molecule. They will dissolve in a different way. They will have a different chemical reactivity. So they are different compounds. And they can be so different that they can even be from different families. For example, look at these two compounds here. They both have 5 carbons and 10 hydrogens. However, the structures are totally different. This is a cyclic alkane. There are only single bonds there in that molecule. Carbons and hydrogens are only single bonds. And this one is an alkene. It has a double bond. So not only are different, like the structure is different, but they're actually from 2 different families, alkanes and alkenes. The more carbons you've got, the more isomers, structural isomers you can have. And I've got here a little table about how, if you have 6 carbon atoms, you can have up to different 6 structural isomers. And if you have 20 carbon atoms and 42 hydrogens, you can have over 350,000 different compounds that they all have that same molecular formula, C20H42. And another interesting type of isomerism, especially with special relevance in pharmaceutical industry, but also in biology, in biological systems, because shape recognition is really important in biological systems. If you think of our taste buds, our olfactory sense, the way enzymes work, the whole, is the right shape will attach to the enzyme is really important. Optical isomers. Optical isomers are isomers that in which the atoms are they all have the same molecular formula, because that's what an isomer is, and the atoms are actually bonded in the same way. Look at these two compounds there, the two types of carbon. They seem identical, but they are not, and they are not because carbons that make single bonds, so this carbon here and this carbon here, that make single bonds, they are not square, they are tetrahedral. And we draw these, we try to show this is a carbon in the middle by doing this. And this is what we are trying to represent. We are trying to represent this carbon and this substituent A and this substituent B are in the same plane. It will be the plane of your screen. And this substituent here is coming from your computer screen and pointing at you, or from your device screen and pointing at you. And this one with the dash lines is pointing away from you, at the back of the screen, or wherever you're looking at this video in this moment. So carbon, when it has 4 bonds, carbon when it has 4 bonds, is not square. It's not planar, it's actually tetrahedral. It has a 3D structure. When you have a carbon attached to 4 completely different things, then you have what we call a chiral carbon. And those 2 carbons, those two compounds I've drawn there, are mirror images of each other. So, okay, they look identical, but because all the substituents are different, when you're trying to superimpose them, you can't. Because if you think of rotating one of them, imagine you're trying to rotate this one to make it overlap with the other one. Yes, the A, the B, and the C and the B would overlap. The Y and the X would be swapped the other way around, so you would not end up with the same compound. Those molecules are said to be chiral. And chiral compounds tend to have the same physical properties in the melting points, etc., because melting points, boiling points of solubilities, because the atoms are attached in the same way. But because their three-dimensional structure is different, the atoms are pointing at different parts of the space. They tend to have slightly different chemical properties and especially biological properties. And for example, we've got here the example of carbon minus and plus that actually have a different taste. The one on the left is spermine, the one on the right is caraway, because it interacts in a different way with our taste buds, our olfactory receptors. And the cyanide drugs are often isomers of well-known drugs. So an example of two optical isomers in which one is an over-the-counter medication, the congestant, and the other one is an illegal drug, is methamphetamine. And if you look at this carbon here is the one that has the 4 different substituents, and it's carbon-carbon single bond. Sorry, it's a carbon that only has single bonds. And well, you have 2 different isomers that one of them is a perfectly legal over-the-counter medication used for inhalers, and the other one is an illegal stimulant, so meth.